So, good morning, everyone. Can you all hear me?
Yes, sir, we can.
Okay. All right, so yesterday we did quite a bit. We looked at the for loop and how to use it effectively in Python. Python has some interesting uses for the for loop. We can iterate over any compound data type that is iterable. That is a sequence. Okay, so we can use for loop to iterate over a sequence, isn't it? So that's what we did. And then furthermore, we went ahead and looked at lambda functions, isn't it? So we did the for loop, while loop, and then we saw the for loop for compound data types that are iterable. And then we saw the lambda function, that is one-line functions that we can use, okay, using the lambda keyword, okay. So are there any questions with regard to yesterday's class? Anyone? So I think I'm yet to post the materials. I'll do that later in the day today, both for today's class and yesterday's class. Have I posted the material? I don't think so. Can you all hear me?
No, sir, you didn't post anything.
Okay, thank you. All right, okay, so I'll do that today, but if there are any questions, feel free to ask me. Today what we will be doing is we'll go into a further application of the for loop. We have seen the for loop already to use over a compound data type, how we can move over each element in the compound data type. So using the for loop, we can iterate over every element. Now there are more uses for the for loop, okay, and today we'll be seeing another uniquely Python concept, and this concept is called comprehension, okay. So it's called comprehension, and we'll be doing comprehensions today, okay. So I'll just type out what we'll be doing today. It's called comprehension. Okay, and so we'll be doing Python comprehensions today. Okay, these are a very interesting programming concept. Like yesterday we saw about the higher order programming, isn't it? We saw how we can pass a function as a object, how we can treat a function name as an object, and how the function can be passed as an argument to another function. So functions can be used as arguments, and then we saw how we can apply the function to a set of elements, mutate the set of the list of elements, or we can take a list of functions and apply it to some element. So all this we saw yesterday. So today what we'll be seeing is called this comprehension, and depending upon the data structure we are using, this comprehension is variously called as list comprehension, dictionary comprehension, and set comprehension. Okay, so we have three types of comprehensions, that is list, dictionary, and set. Okay, so if you are able to learn at least one of these very well, the others are also similar. Okay, so what we will do is we'll try to work with the list comprehension. Okay, and that's what we will do today. Okay, so let's take this problem. What I want to do is I want to find, given some list, let's say this is my list. So I have a list like this here. Given this list, I want to find the cubes of all the numbers in this list. I want to create a new list that has the cubes of all these numbers. How will I do this? I want to create a new list that contains the cubes of all the elements in L. How will I do this?
Using for loop.
Use a for loop. Excellent. Okay. So what we can say is, Okay, so let's go back and let's try to write a program for this, write a function for this. Okay, so so all of you try to write this function. We want to find the cubes of all the numbers of a list. So let's say def cubes of some list, isn't it? And then we have to give a doc string. What does it do? Returns the cubes of all elements in L. Again returns it as a cube. Okay. So now we say for number in L, isn't it? We can iterate like this, and then we have to form a new list, isn't it? We can say L1 dot append, okay, of what is it? Num cube. Okay. Will that work? What is the last statement I have to give? Anyone?
The return, I guess.
We have to give a return from the function, return L1. Okay. Now will this function work without any errors?
So we have to predefine
Sir, actually,
the list
L1,
L1.
I don't understand how the L1 thing works.
Sorry, will this work?
Sir, we have to define L1.
Yes, L1 is not defined, no sir. L is the list and L1 is not. No.
Okay. Okay. L1 is not defined. Okay. But Python is dynamically typed, isn't it? Okay. Now, but there is the problem here. Now, what is the problem? Given the Python is dynamically typed, when you say L1 dot append, append means it's adding to the last element. So the first time it encounters the L1, there is no last element at all, so it will be an index error. Okay, so that is why L1 has to be initialized, because the append will assume that there is a last element. Since that is not found, it will return an error. So you have to initialize L1 as an empty list. Okay, now this will work, isn't it? Okay, so now I can say that if L is equal to 1, 2, 3, 4, 5, okay, I will say print cubes of L. Okay, all right, so let's try to run this program. Alright, so now it runs and gives us the output, isn't it? Okay, so it's very simple, isn't it? So we just write a function and then we do this. Okay, now you see that all we are doing is we are iterating over each element in L and just adding the new value, isn't it? Okay, so we are doing something over the entire length of the list for each element in the list. Okay, so whenever you have to do something for each element in the list over the entire list, we can use something known as a comprehension. Okay, so what is the comprehension here? What we are doing is we want to get num cubed for every num in L. So this is exactly what we are doing. In English, this is what we are doing. We are getting the cube of the number for num in L. You are iterating over the elements in L and for each element. So this is where we are saying this is the input object, and this is where we are assigning the every element to num, and here we are getting the output that we want. So this is the output. So you see, when we write the comprehension, the output is given first and then the assigned variable, and this is L is the input sequence, and this is the syntax for writing the comprehension. And this is what we want. And now you want a list as the final data structure. So we just say like this. This whole thing in a list, okay? And we can say that some other list is equal to this, okay? So L2 is equal to num to the power of 3 for num and L. Now suppose you say print of L2. And this statement I will comment out, this print. I only want to print my L2. Okay, now see what happens. So you see we get the same result. Okay, so instead of writing all this ton of code, isn't it? Defining a function and this and that and everything, some 6 lines of code, in one line, in one statement, in one expression, we can generate that particular outcome. Okay, and all we have to say is the output for the assigned variable in the input sequence. What do you want to do with the output? That is what we give here. That is it. Okay, and with that we'll get the final list that we want. And since you are putting it within this sort of a bracket, it's called a list comprehension, meaning that the final output is a list. Okay, so what comprehension we call it depends on the final output, not on the input sequence. So this is called a list comprehension, not because the input is a list, but because the output we want a list data type. How are we specifying that the output is a list data type? Because we are giving this square brackets. Okay, so this is a list comprehension. Similarly, if you were to do this like this, you can't do that, but you can say that let's say you want to create a dictionary from this. You want to map the index of the element to its cube. So to get the index of the element, we have to say enumerate of L. Correct? We did this yesterday, isn't it? We say enumerate of L, and then when you unpack the tuple that is returned by the enumerate, the first value is the index. So for index comma num and enumerate, and here you want to map index to num of 3, okay, and this you want to put within this bracket, and then you will see what happens. Okay, so now we are giving a dictionary comprehension. Let's see if this works. So now if you see, we have a dictionary out of this. Okay, so 0 is mapped to 1, 1 is to 8, second element to 27, third element to 64, 4 to 25. So you see we can even generate a dictionary out of this comprehension. Okay, so this is just a very simple example where you see we have done many concepts here. That is, one is we have done tuple unpacking here using the enumerate. Then we use the for loop to iterate over each element, and for each element we are returning a key value pair. How are you returning the key value pair? Because you are saying in colon num cube. Okay, so this is the key value pair, and this we are saying is a dictionary data structure. So L2 has now become a dictionary. It's no longer a list, it's just a dictionary, isn't it? Alright, so okay, so I hope that's clear that we can switch between a list comprehension and a dictionary comprehension depending upon the output type that we specify. So that is just in our hands. Okay, the calculation we are doing remains the same, but we can switch the output type appropriately using the right syntax. Okay, so let's explore comprehensions in a little more detail. Now that we are introduced to comprehensions, let's look at list comprehensions in some more detail. Okay, so for this I'm going to go to my script. Okay, all right, so okay, so you see, so this is what we did just now. That is, we used a for loop to create a list of cubes. Then we saw a comprehension. What is the equivalent comprehension? We just say num to the power of 3 for num and nums. That is the name of the list here. You see nums. So, or you can say L, isn't it? And we put it within square brackets to indicate the output is the list. All right. Now, suppose I want the list of cubes of even numbers, isn't it? So now I have to check whether each number is even, isn't it? Okay. Only the even numbers in num I want the cubes. So how do I do this? I have to add a if statement, isn't it? So let's see how we can do this. So now I want to change this to cubes of even. So I'm just going to write another function here. And how will I do this? So for cubes of even, I have to first say for num and L, I have to check whether num is the even number or not. If num percentage 2 modulo 2 is equal to 0. Only if it's even number, then I want to append to L1. Okay, so L1 is L1 even, isn't it? So this function is basically cubes even. Okay, and now I can say what can I say? Okay, I'll just say print cubes underscore even of L. All right, let's see what happens. Oh, 8 and 64. Okay, so you see my only two numbers are given, 2 and 4, isn't it? So therefore, it will be 8 and 64. So only two values are given as the output in the list. Okay, so the new list has only 8 and 64. Okay, now you see that we have to add a if statement and the code becomes longer. Now let's see how to do this using a comprehension, and this shows the full power of the comprehension. Okay, so we can do this using a comprehension, the same comprehension. Okay, and what we do is, let's see this. What I'm going to do here, okay, so let's do a list comprehension now. So I'm going to do a L2 Are you all with me? Can I hear someone speak?
Yes, sir.
Okay, so I hope you are all working on your own idle, following the class. Okay, so now we are going to do this. Okay, I'll show you how to do this in comprehension. Okay, so as usual, the comprehension must take an input sequence and then it must have an assigned variable to each element for num and L. Now for num and L, what you want to do is you want to raise it to the power of 3, but only if the num is an even number. So the if condition can be added to the comprehension. Okay, so the comprehension can take an extra clause, and that extra clause is the conditional and it is permitted. For num and L, if num percentage 2 equal to 0. I can just add this entire if statement just to the end of the comprehension. Okay, alright, so this is how the full comprehension works. So it can take a output, and this is the output expression, and it takes the input sequence, and this is the assigned variable, and it can take a condition. The condition can be given at the end. Okay, and this is the full form of the comprehension. Okay, and in this just one single phrase, just one single statement, okay, we will do all our calculation. You will check for the condition, you will iterate over the list, and you will get the output, and finally you will get the output in a list, in a nice data structure that is a list. Alright, so let's see what happens. Let's just run this. So again we should get 8 and 64, isn't it? Okay, only this is the only one that is going to be printed, print of L2. So let's see what happens. So again 8 and 64. Okay, so the conditions also work. Alright, so this is the power of the comprehensions. Okay, and once you get used to the Python syntax, okay, you'll find that you're sort of drawn to these comprehensions. Okay, that is, I know you'll never ever imagine that you are programming previously without using comprehensions. You'll use comprehensions all the while. Okay, so these are a very powerful feature in Python, and they are a great shorthand for doing a lot of calculations. But it's also very intuitive of how they work. So once we understand how to use them, they become very, very handy, and they can compress a lot of code into just one single line. Okay, so and in fact you will wonder how you ever did some programming without using comprehensions. Okay, but it takes some time to get used to. Okay, so these are the elements of the comprehension that I'm trying to emphasize. Okay, one is the input sequence is only given here. So this is the input sequence, and this is the output expression that you give right up first, and this is the assigned variable. and then you can give this conditional expression at the end. Okay, so output expression for assigned variable in input sequence if some condition. The if statement is optional. Only if you want you can give a if statement, like we saw earlier. We did not give a if in the first time round. So without the conditional you can just specify, and that will be a valid comprehension. You can also give if statement, that is fine. And the if statement may not be restricted to one condition. As you know, the if statement allows for compound conditions, and the same allowance is also allowed here. Now you can have compound conditions, multiple conditions can be given here. Alright, so all this is fine. Okay, so alright, so let's look at some more examples. Okay, so this is one condition that we are doing here. Alright, so let's look at some examples further here that we are given. So this is how we do for cubes. Ordinarily, if you use a for loop, and what is the equivalent list comprehension? The syntax is expression. That is the output expression, isn't it? What is the output expression for variable and iterable or sequence, isn't it? And if condition, an iterable sequence is what I will give here. So cubes of even is equal to num to the power of 3 for num and nums if and only if num percentage 2 is equal to 0. Alright, so that will work. Okay, now suppose you want to have two sets of conditions. Okay, that is, you say if num is an even number you do one thing, if num is an odd number do something else. Okay, so for every element in the list you will do something. If it's an even number I want you to cube it. If it's a otherwise that is an odd number you just square it. Okay, so that is what we want to do. You see the problem statement. You want to cube the even numbers and square the odd numbers. So how will we do it using for loop? So for num and nums we say if num percentage 2 equal to 0, you say that list append num to the power of 3. Else that list you only append num to the power of 2. That is, we are just squaring the number. So this sort of a ternary expression is also possible in a list comprehension. So how do we do? So the syntax is the expression for the true condition. Okay. Else, what is the this is the expression, isn't it? Some expression if you want, if condition, else it's false condition, so it is some other expression, isn't it? Okay. Okay, so num to the power of 3 if num percentage 2 equal to 0, else num squared for num and nums. So now you see when you have a ternary expression, the if and the else come before the for. Okay, so the difference between this and this, you please note, here the if statement comes at the end. But if you have a ternary expression, you have to give it before the for. Okay, so you say num to the power of 3 if num percentage 2 equals, because this expression is only valid if num is the even number. Else you want to square it, so else num squared for num and nums. So even this works. Okay, so cascading if else will not work, but if you have just if and else, that alone you can that can be replaced using a comprehension. Okay, so even this I may not advise unless you become very familiar with Python. But this this using the if statement here everyone should be fine with. Okay, so this should be fine for everyone. Once you get some practice, I think you can also go into this particular syntax where you do something for every element using a ternary condition checking. All right. So all right. So that is what this is. Okay. So this is all like how you do the list comprehension. Now suppose let's say you have a 2D matrix, isn't it? So a matrix, there's not an explicit matrix data type in Python, but we can use a list to represent a matrix. How do we do that? We use a list of lists where each row is a list. Okay. So we have a list of 2 lists. Okay. And since it's just 2-dimensional, one list for every dimension. So we have a list of 2 lists. Alright, and suppose we want to flatten this matrix. By flatten we mean we want to make it 1-dimensional. You want to get all the elements in order in a single dimension. So for that you can just say some matrix is a list of 2 lists, and this is our example that we are using. And then we say the initialized items because we're going to append 2 items. Now you say for row in matrix, that is you're going element by element, the element are lists, Now for each of this list, we can say for item in row, that is now we are coming to 1, isn't it? Okay, so we can probe deeper into the matrix, and then for item in row, you just say items dot append of the item. Now you are flattening the matrix. All right. So this can be done using a comprehension. There is a equivalent list comprehension, except that you see there is a nested loop here, and the nested loop can also be used in the comprehension. All we say is items is equal to item for row in matrix for item in row. Okay, and this is where we are defining the item. Okay, and this is the input sequence, and this row is taken from the assigned variable here. So for item in row, and the output expression is just the item alone. So you will get 1, 2, 3, 4. All right, and the matrix is flattened. In one single statement, the matrix has been flattened. All right, so these are all the applications of the list comprehension. Just some normal element processing of a list. Okay, normal list processing. Second, you want to process the elements upon a conditional. You want to check for a condition and then process the elements. Third, you want to use a ternary expression, that is, you want to check for a condition and then process. If true, one expression; if false, some other expression, isn't it? So that's the ternary expression. And finally, we want to use a nested loop, and that is also possible within a comprehension. Okay, so we have so many different possibilities. All right. Okay. Now I already showed you how to do a dictionary comprehension. It was just a small change in the syntax, a very reasonable change. Similarly, we can also do a set comprehension. All right. Okay. So let's see how to do a set comprehension. So all right. So to do a set comprehension, let's go back to our fruits. One of our favorite lists, isn't it? Okay. So let's say here we also have mango. Supposedly the king of fruits, and then let's say we have strawberry, isn't it? Okay, and then this is also the, okay, this is enough. Okay, all right, so this is my fruits. Suppose I want to make a set of the lengths of each of these elements in the list. Okay, why do I want to make a set? Because some of these fruits have the same length, and I don't want the length to be repeated 2 times. So if I make a set of this, then the set will remove the duplicates. Okay. All right. So let's see how to make a set of this. Okay. So set fruit. So let's say fruit set. Okay. Now you see I'm going to open Anglo braces. Now this looks like a dictionary, isn't it? Okay, but we also know that a set is also represented by the Anglo braces. When we print a set, it is given in Anglo braces. Okay, so what is the difference between a dictionary and a set? Anyone?
Sir, set doesn't have any index. Dictionary has index.
Excellent. Okay, dictionary, we can't say it has an index, but the right word for that is key. Dictionary has a key and it has key value pairs, whereas set has only values. Okay. I mean, set has only, it doesn't have key value pairs, it has only like single elements, isn't it? Okay, so, but a dictionary, every item must be a key value pair, okay, and they are separated by a colon when we print the dictionary, okay, and we don't say the dictionary has an index. That would mean the dictionary is indexed and it has the order. On the other hand, contrary, the dictionary is unordered, okay, the dictionary only has keys, the keys are unique and you can access the dictionary using the keys. Isn't it? Okay, and but as such we don't call it as an index because the index will imply ordering, but there's no ordering to the dictionary. The keys are, you can have the keys in any order. The keys are unique, but they can be in any order. Alright, so now we have the fruit set. So again, to create the set comprehension, again we use this, except that if you want a dictionary, you have to say key colon value, and then it will know that it is a dictionary comprehension. Okay. But here we only give some value alone, some the single elements alone. And what is this element? Basically, we want for fruit and fruits. What do we want to find out? And we can close this Anglo braces here. We want to find their length. So we just say len of fruit. And boom, our set is created. Okay, we just say len of fruit for fruit and fruits, that's all. Okay, and now if you print fruit underscore set, now you see it is 10, 5 and 6. Okay, so it's in no order, isn't it? So 10 is the last length, it is strawberry, but how did it come in the front? It comes in the front because the set is not ordered. Okay, so next time you give the same list and do a set for this, you'll find the lengths in a different order. Okay, so that's basically the meaning, they are not ordered. So okay, so both the dictionary, the set especially is not ordered. All right, so 10, 5 and 6, so there is 5, apple and mango both are 5, since it's a set it's only represented once, and banana and cherry both are 6, but as a set it only comes once. Okay, so it's the same construct, if the input sequence here, the output expression is here, and this is the assigned variable, everything is the same, the syntax is the same for the comprehension, except that it is a set comprehension, so we give these angular braces. Okay, alright, so that is all. There is no other change, you just give the angular braces. And with the dictionary comprehension, you have to give both the key and the value separated by a colon, and then what is within the angular braces will become a dictionary. Right now it is a set, isn't it? So let's say type of fruit underscore set, and you see it's a class set. Alright, so that is, we have the unique length. So when we want the unique length, we say we can put it as a set comprehension. Alright, now let's say dictionary comprehension, isn't it? Okay, so this we have already done. Fruit is to index for index comma fruit and enumerate of fruits, isn't it? So all this we have done. Okay, so and we've done the len of fruit as well. So this is fine. Okay, so this is how we do the dictionary. Okay, I'll just do this again for you. Okay, so we want a dictionary comprehension. So fruit lens, and if I just print fruit lens here, it's mapping the fruit actual string with its length. So apple is 5, banana is 6, cherry is 6, mango is 5, and strawberry is 10. And if I say type of fruit underscore length, okay, already it's a dictionary very clearly, so it's a dictionary. Alright, so everything we did with list comprehensions, okay, the same syntax holds for both set and dictionary. Everything can be done with set and dictionary as well, except that the returned data type is a set in one case, or it's a dictionary in the other case. Okay, so in fact I can use a condition here, if condition at the end. Okay, and then I can also say that okay, if let's say if len of fruit, let's say the len of fruit should be an even number, only then I want the this thing, isn't it? Okay, I want the len of fruit to be an even number, and only then I want to create this set. Okay, so let's say only then I want to create the dictionary. So now if I say fruit underscore length, so now you see I have banana, cherry and strawberry, but not apple and mango. Okay, so I can use a if condition at the end, then I can use a ternary expression if and else. I say fruit is colon len and fruit. Okay, how do I use the ternary? Let's just try the ternary. Okay, so so fruit is len of fruit if it's this thing, else I say what is the expression I want. I just say fruit, I have to give again a key value pair, isn't it, for all the rest. Fruit is mapped with, let's say, not even. It is mapped with a string called not even, okay, for fruit and fruits. So let's see what happens. Apple and mango should be not even. Oops. So I think the ternary will not work with the dictionary. Else, okay, this is working. All right. Okay, so the ternary expression does not work with the dictionary. Okay, so that is interesting. all right, but we can have multiple if conditions, okay, at the end, and we can also do probably a nested for. But these are all advanced constructs. We don't really want to do that in a dictionary, but they're useful when we are creating lists. Okay. In fact, in Python 2.x, only the list comprehension was available. Only in Python 3, the dictionary comprehension and the set comprehension have been introduced. So these are brand new concepts, the dictionary and the set. So I think the ternary expression has not yet been, sort of clarified for the dictionary. So it's not available for the dictionary. So I would not recommend using the ternary expression for the dictionary due to unpredictable behavior. But otherwise everything else works. You can have conditions in the dictionary and the set comprehension as well. All right. So that's what we have for this comprehensions. All right. So yesterday when we were doing the higher order programming, I told you that there is actually a Python function to do to apply a function to a list of elements, isn't it? And that function is called map. Okay, so we can do this map and filter in Python. All right, and basically instead of writing a function that takes a function as an argument and applies it to all the elements, the map function will do it for us. Okay, and the map function is one of the higher order programming tools that Python provides us. So this is another unique Python feature that we have. Okay, and basically what it does is it applies a function to every element of a sequence, okay, and returns a list or an iterator. So we are only working with Python 3, so it returns the iterator. So let's say we have a list like this. Let's say we just have this fruits. So we have fruits here, and we want to find the len of all elements in the fruit. Instead of using a comprehension, what you can also do is you can say map. The first argument is what is the function you want to apply, and the second is the sequence on which you want to apply the function, and the function will be applied to every element in the sequence. Okay, and now this is what you get. Now since it's an iterator, we need to flatten it out, and you can flatten it out by saying list of map of len comma fruits, and you see 5, 6, 6, 5 and 10. Okay, so it is just like what we had earlier using the comprehension, isn't it? Okay, but with the comprehension you can do some if condition, you can do multiple compound if conditions, and you can also do some loop nesting. You can do nested for loops, but the map will just apply one function to one sequence. That is all it will do. Okay, so for simple cases map is fine. For more complex instances we have to use the comprehensions. All right. Okay. So instead of giving a function name here, you can also define inline lambda functions, isn't it? Okay. So let's say what is the inline lambda function we want to do, isn't it? Okay. Let's say I just want the first letter of each fruit, and I want that to be returned. Then I say map of lambda, and if it's a fruit, what I want to do with the fruit, I want to return the first letter of the fruit. Fruit of 0, comma fruits, and what is the sequence I want to apply the map? It is that, and now you see it's apple, banana, cherry, mango and strawberry. Okay, so I can combine my lambda expression with the map function. Okay, so everything is possible, isn't it? Okay, so what are these equivalent list comprehensions? We just say len of fruit for fruit and fruits, and we just say fruit of -1 for fruit and fruits. Okay, that is the example we are working with. All right, so similarly we can also use a filter. Okay, and filter is another function. It's like a if condition. Okay, so we've already seen how to use the if condition in the list. Now here is a filter. Okay, and basically what it does is it again takes some function and it applies the function to every element in some sequence. So you have to give the sequence here, and it returns a list. Okay. Now the function can be basically something that returns true or false. Okay, so in map, when you look at map, the function returns the expression, the function returns the value, but when you use filter, the function should always return either true or false. That is, it should be a Boolean construction. Okay, so it should be like a condition that you give. Okay, and if it's true, then those numbers in num will be returned, the rest of the numbers are not present. Okay, so filter is just used to filter the values in a sequence so that you get only the values of interest, and these values of interest you define based on some condition that returns true or false, and you give this condition as the first argument, as the function here. So you can say, let's say now I have this this thing, isn't it? So okay, so here what we are doing is we are saying lambda x, if x is a even number, and then you return from nums, and numbers like, okay, you only get 0, 2 and 4 because numbers 0, 1, 2, 3, 4, 5. Alright, so because it is range of 5, okay, range of 5 is 0, 1, 2, 3, 4, isn't it? Alright, so let's do a filter in our own examples. Okay, so we have seen map, let's do a filter. So let's say filter, and we want to say what is the function we want to use, isn't it? Lambda, and let's say fruit is what we are using, and we want to say fruit is dot is lower, is it in lowercase? Okay, and then we just give the input as the fruits. Okay, and since now it is a iterator, we have to flatten it out, and we can do it using a list. So everything is in lowercase, but suppose I were to say this as is upper, isn't it? Let's see what happens. It's an empty list. Alright. So like this I can give any function, is lower, is upper are Boolean functions, they return a true or false, so we can use them as a function for the filter, and then we can find out what elements in the sequence satisfy that particular condition. So map will basically mutate every element into something else. Filter will return only those elements that satisfy a condition. Now this filter can be given as a comprehension, isn't it? How do we give a comprehension here? We just say this, that is fruit, if for fruit in fruits, and we give a condition if fruit dot is upper. That's it, isn't it? Okay, that is a false, because none of them is in uppercase. But if we say is lower, we get everything back. Okay, so it's just, so these are all variants on the list. Okay, sometimes these are more intuitive to use. When all you want is the simple list comprehension, only a if condition, but no expression is here, isn't it? You can't use any expression, the same element is returned. You only filter the sequence, but you're not changing the elements, isn't it? So it's only fruit here. And in map, what we are doing is, we are only applying a function, but we can't check for any condition. So whenever you want to both have an expression as well as check for a condition, only the list comprehension will do it for us. Okay, so but when you just want to check for a condition and return the same elements, a filter will do it for you. When you just want to have a function applied to every element, the map will do it for us. Alright, but you can also combine the map and the filter, isn't it? So you can combine the map and the filter. Okay, how will you combine the map and the filter? Let's say I want to find the length of the elements that satisfy if they are lower or not, isn't it? Okay, I want to find the length of the elements only if the length is a even number. Okay, so how will I do this in comprehension? I'll say len of fruit for fruit and fruits if len of fruit %2 equal to 0. So I get 6, 6 and 10, isn't it? Okay, that is corresponding to banana, cherry and strawberry. Let's see how to do this using a map and filter. We want to map, and what you are mapping is the len. But what are the elements on which you are mapping? They have to satisfy this condition. To satisfy this condition, I can apply a filter and get it back. So I can say filter of, what am I trying to filter? Lambda fruit, len of fruit, %2 equal to 0, comma, and it is my fruits is my input. Okay, so when I do the filter, now I get a new list. with only those that satisfy the condition. On this new list, I'm applying the map function, that is the len. So this is going to work, isn't it? So now I'll get the iterator. So in order to see what it contains, I can flatten it. Now again I get 6 and 10. Alright? Is it clear to everyone? Alright? So what have we done today? So we have introduced this concept of comprehensions, and we saw how to create list comprehensions. And within list we saw there are many, within list comprehensions we saw there are many things we can do. One is just saying that some expression for the variable in the input sequence, we are just transforming the input sequence into a new output sequence. Second, we can add a condition to this. Okay, we can add further conditions and only get certain only if the values satisfy the condition, we can get the expressions to operate on the values. And then we can then have a ternary expression. We can have one expression if one condition is true, and if it's false we can have another expression. And then we saw we can have a nested for loop within the list comprehension. Okay, so we can have nested for loops, and we can have compound if conditions, and we can also have ternary expression, and all of this could yield us a list comprehension. Okay, and then we saw that this is there's simple extension to both set comprehension and the dictionary comprehension. They don't have the fancy features of the list comprehension, but for straightforward comprehensions we can use a set when you want only unique elements, put them in angular braces, and give what is the comprehension we want to do. That is the expression for the variable in some input sequence. Similarly, for dictionary comprehension, we have to give both the key colon value, and the rest of the construct is the same as for the list and the set comprehensions. Alright, so we saw all these comprehensions, and we saw a lot of examples with these comprehensions. Then we also saw this higher order programming functions called map, okay, and filter. Okay, in fact the comprehension is a very high order programming, but there are some inbuilt functions as well that will help us do what we were trying to do yesterday, isn't it? Where we are trying to apply a function to every element. Okay, and that is what the comprehension will do in its simplest form, and we have the map function for that. So in sometimes some of us may prefer to use a map, and if you want to just apply a condition to every element, then we can use a filter. Okay, and for that also we have the comprehensions, equivalent comprehensions, but we may prefer to use filter in these instances. If you want to combine both an expression as well as a condition, then we can use a map filter sequence, just like we used here. You can use a map followed by a filter. First the filter will act and give us only the relevant elements, and then the map will apply the function on those relevant elements. Okay, that's called a map filter construct. Okay, so today we have seen two key concepts in Python. One is the comprehensions, second is the map filter construct. And the comprehensions are the more general. Everything the map filter can do, the comprehensions can also do, and the comprehensions can also do something more. All right. So try to practice with more comprehensions. Okay, I will be providing all the script in the session transcript today. Okay. So are there any questions?
No, sir, understood.
Oh, great. Fantastic. I'm happy to hear that. The first time you're doing and it's all clear, that is excellent. Okay, so these are some really advanced concepts in Python, and if we can do the comprehension, we'll be able to solve a lot of problems. Okay, these are very helpful in solving problems. Okay, anyone has any questions?
Sir, actually, the first one you did, though, sir.
First one?
Yes, because Python is dynamic.
Ah.
So that can be only done in editor, not can be done in console.
No, it can be done in both. It can be done in both. I mean, editor or console, it's still the same Python. Okay, but you have to in the editor you can write the full program, isn't it, and then run it. If you're doing it in the console, the namespace is preserved. So first you can initialize the empty list and then do it. It will work. You have to give command by command. Okay.
Sir, but in console, L1 it is coming like L1 is not defined for me.
You first have to say L1 is equal to an empty list. Did you say that?
Okay, sir. Okay, sir.
Even in the editor we say L1 equal to empty list, because when we append, as I said, the append method looks for the last index and then adds to the last index. But in the first time we are entering the loop, when it says append, the list is not there. There is no last element, so the list has to be initialized. That is why it has to be initialized in this instance.
Okay, sir.
All right. Any other questions? Okay, no more questions. Excellent. I will post all these materials today. Okay, and there are plenty of materials available on the web, net, anything. It will give you a lot of. Be sure to make use of these online resources. I mean, there are so many resources for Python, for practicing Python, and these are the general concepts. There will be tons of resources. Make sure that you go through at least some of these online resources. Okay, they are very, very easy to find, and practice some of the problems they give. Sometimes they give their own like a coding platform. You can just give the code and see if it is correct or not. Okay. So I'm sure you guys know more about all this. You can exchange these information in the classroom as well. Okay. So try and practice more of these comprehensions and higher order programming. Okay, and try to write some functions as well. All right. So I'll be posting all the materials. Okay, and we'll also plan for a assessment. Okay, so with this, I think we come to the end of the first unit. Okay, and but we will do some problems, and we'll do some debugging maybe, and we'll try to make sure that we are also writing programs, isn't it? Okay, and after this, we'll have a assessment. Okay. All right, everyone. If there are no further questions, isn't it? Okay. All right, so yeah. So have a nice day. Bye.
Thank you, sir.
Thank you, sir.